Okay, I wanted to do the next part separate, the two open-ended questions on your polynomial review. So, during the period of 1988 to 2000, the average cost M in dollars of a new car and the average cost T in dollars of a new motorcycle can be modeled by the following functions. M equals, well, you could read that, where T is the number of years since 1988. How can the difference, so we're subtracting, I see the key word there, difference, of the cost of a motorcycle and the cost of the car be expressed? Since they put motorcycle first, you need to put that first. So we got negative 143.29 t squared plus 765.49 t, ignore that, plus 11,489, and then we are going to subtract the cost of the car. So we got 291.2 t plus 12,867. Just like when we subtracted before, we have to distribute the negative sign, so it's going to become negative 291.2 t minus 12,867. I'm going to leave this in here for right now because it's really long to rewrite, and I'm going to go and combine my like terms. This is the only t squared, so that's going into my answer, negative 143.29 t squared. Plus, now we have like terms. They're different signs, so we subtract. And when we subtract, I know it's going to be positive because the bigger number is positive, is 474.29 t. And then finally, we have our constants. So one's negative, one's positive. This time the negative is going to win out. The negative is bigger. And that's going to be 1,378. Now, we got to remember that for the next part. So for the next part, we want to evaluate it. What was the difference in 1997? Since 1988 was the first year, we count that as year 0. So 1988 counts as year 0. And if we count up till we get to 1997, so 1989 would be year 1, 1990 would be year 2, so on and so forth. So when we get to 1997, that's the 9th year we're looking for. So using that expression we had up above, we just want to plug in a 9 and evaluate this. So negative 143.29 for the t, I'm going to plug in, because this t stands for years, I'm going to square that, plus 474.29. There's another t, so I'm going to plug in another 9, and then minus 1,378. You type that into your calculator, make sure you hit squared. You could evaluate each part individually, but what's going to happen, so this is 81 times this, 9 times that, and then you're going to be left with two negatives. I would combine them first and then subtract this, but lo and behold, $8,715.88 is the difference between the car and the motorcycle. We'd have a swimming pool that's going in our yard, and then we have a sidewalk going around two sides of the pool. So we want to write a polynomial. Polynomial that we would write would be 54 minus x. X stands for the sidewalk, so we have this whole side, but we want to know the pool, so the whole side minus the width of the sidewalk. Now for our length, we want to do 42 minus x, the width of the sidewalk. When we distribute this, 54 times 42 is going to be 2,268. 54 times negative x is negative 54x. X, now we distribute the negative x, right? Negative x times 42 is negative 42x. And a negative x times a negative x gives me a positive x squared. I want to put that in standard form, so I'm going to start with my x squared. I'm going to combine my like terms here in the middle. That gives me negative 96x, and then positive 2,268. So that's part A. That's the polynomial expression that represents the area of our pool. What is the area if the sidewalk is 5 feet? Well, you could plug a 5 into each of these. I think that's the intent of this question. But years ago, a student told me, and I really liked it, they plugged their 5 in up here. So they did 54 minus 5, and then they're going to do 42 minus 5. 54 minus 5 is 49. 42 minus 5 is 37. 49 times 37 is going to give me 1,813 square feet is going to be the area of the pool. If you do this, this is 25. This is negative 480. This is 2,268. Just bring that down. If you add your positives, it's 2,293. 2,293 minus 48. Lo and behold, still gives you 1,813 square feet. So either option. You don't have to do both. I hope you enjoyed the video, and I hope you get a great grade on your test.